Have any of you ever had to use your CUID to gain access to either a residence hall, a dining hall, or an education building? If the answer to any of those questions is yes, then you have used a form of identification. Good morning, my name is Colton Rudd, and today I will be talking to you about identification applications. There are three categories of identification, and those are knowledge, possession, and biometric. Knowledge is something remembered like a coded number or procedure. Examples would be a PIN, a combination, or even a password. Possession is something carried like a token or a card with a magnetic stripe, such as your CUID. Biometric, which is what I will mainly be focusing on today, is something inherent to the individual, such as a physiological or biological trait. Examples of these are the fingerprint, iris, voice, dynamic signature, and face recognition. First, let's talk about fingerprint recognition. It's the most well-known and publicized biometric. It is unique and consistent, which is why it has been used for over a century, and has become automated due to advancements in computing capabilities. Another advantage is that it is easily acquired and that there are numerous sources, meaning that there are 10 fingers on both hands. The concept and approach for fingerprint recognition is that a fingerprint consists of a series of dark lines that represents the peaks and the valleys of the friction ridge skin. Identification is based primarily on the minutiae, which is the location and direction of the ridge endings, and the bifurcations, which are the splits along the ridge paths. And as you can see in this diagram, the ridge ending, or the minutiae, is where a ridge ends, and the bifurcations are where a ridge actually splits and diverges into two separate paths. Hardware types that allow for the acquisition of these fingerprint recognitions are 4 different sensor types. There's the optical, which is the most common, as pictured. It takes an image of the fingerprint. There's also capacitive, which determines each pixel value based on the capacitance measured. Ultrasound uses high frequencies and sound pressure to generate a replica of the fingerprint. And thermal takes a sweep of the fingerprint and measures the difference in the temperature. For the software, there are 2 main categories of matching techniques. There's pattern matching, which simply compares images of fingerprints for similarities. And the more commonly used are the minutiae-based matching, which analyzes the locations and the directions of the minutiae points, as pictured. The next type of biometric is iris recognition. And this is the process of recognizing a person by analyzing the random pattern of the iris. This is a fairly recent technology, seeing that it was patented in 1994. It is unique and structurally distinct, which allows for it to be used for recognition purposes. The concept and approach for iris recognition is that the iris must be first located using landmark features. And these features and distinct shape of the iris allow for imaging, feature isolation, and extraction. However, if done improperly, resultant noise such as eyelashes, reflections, pupils, and eyelids may lead to poor performance. And this requires the use of a high-quality digital camera. And the patterns of the iris can be represented with what is called iris code, and that is what that block of bytes represents, the block of iris code. Now, the recognition happens like this. 2 blocks of iris codes are compared, and the amount of difference between the iris codes is used as a test of statistical independence. And if less than 1/3 of the bytes in the 2 iris codes are different, it fails this test of statistical independence and concludes that the 2 iris codes are from the same iris. So the main idea of that is failure of the test equals positive recognition. The next type of biometric is that of voice recognition. It uses an individual's voice for recognition purposes. And the availability of devices for collecting speech samples, such as a telephone network and computer microphones, as well as its ease of integration, makes it very popular to use. The samples of the voice are captured dynamically over a period of time, and analysis of the voice occurs on the model in which changes over time are monitored. The concept and approach for voice recognition is that the physiological component of the voice depends on the physical shape and the vocal tract, which contains the airway and the soft tissue cavities. These components work in combination with physical movements of the jaw, tongue, and larynx, as well as the resonance in the nasal passages. And it's the motion of the mouth and the pronunciations of spoken words that are the behavioral components of this biometric. So as an example of voice recognition, we will look at a text-dependent system in which an individual will say a short word or phrase into a microphone, which can be as simple as a telephone. And this sample of the voice is then converted into a digital format. And the features of the voice are then extracted and a model of the voice is created. The quality of the sound, the duration, the intensity dynamics, meaning how loud or soft it is, as well as pitch characteristics and inflections of the voice are the types of features that are included in this model. And after these qualities are enrolled, which means that they are stored in the system, they are compared to the qualities extracted from the sample of the claimed identity, as well as to anti-speaker models, which I will explain in just a second. After this is compared, a likelihood ratio is produced, indicating whether or not the sample came from the claimed identity. And if you look at this model, we see that the input user, Bob, utters "my name is Bob." After he utters this into the microphone, the features of his voice are extracted and are compared to multiple models. The first is that of Bob's model, meaning that Bob's features are stored already and can be compared to his model. And this is also compared to the imposter model or the anti-speaker model that I mentioned. And what this basically means is that other people have spoken similar phrases and their qualities have been stored, so that if his model is compared to the anti-speaker model, then it will show that it is not his voice. And then at the very end, the decision can be made based on the comparison whether or not to accept or reject Bob's claim to his identity. And that's basically how the voice recognition works. However, there are some problems that occur with this. One could enroll a good quality sample of a voice and then try to authenticate from some other type of noisy system, meaning they can be calling in from the cell phone, trying to authenticate, and there could be wind or noise in the background which will affect the qualities that are being registered by the system. And there are also known spoofing attacks in which imposters can mimic a vocal performance if they know what is to be said ahead of time. They can prepare and be able to duplicate the vocal. And text-independent systems are generally used, and these prompt randomly generated phrases so that it's much more difficult to spoof the system, meaning that somebody that's not authorized to have access won't be able to prepare anything in advance. The next type of biometric is that of the dynamic signature, and this uses the anatomic and behavioral characteristics that an individual exhibits when signing his or her name or some other phrase. And this needs to not be confused with an electronic signature capture system, which will only capture the graphical image of the signature, because a dynamic signature includes multiple characteristics, including the direction, velocity, acceleration, and timing of the signature, as well as the stroke and pressure and shape of the signature. So, like I said, the characteristics of an individual signature vary, and these signatures are captured using contact-sensitive technologies, such as personal digital assistants or digitizing tablets. And as you can see here, a signature is broken down and analyzed according to several different aspects. And just one, for example, is the time that it took to perform the signature. These characteristics are also analyzed in the X, Y, and Z directions. And as you can see, the velocity and acceleration are components of the X and Y direction, while pressure, the downward pressure on the tablet, can be analyzed in the Z direction. There are recognition algorithms that account for natural changes or drifts that occur in a signature over time. And these characteristics are almost impossible to replicate because they are so complex and unique to the handwriting styles of the individual. A graphical image can simply be duplicated by a trained human forger. However, one's own signature can vary, making recognition difficult. which is why dynamic signature sometimes will work and sometimes not work so well. The last type of biometric is that of face recognition. And while early algorithms use simple geometric models, modern-day algorithms incorporate sophisticated mathematical representations and matching processes. In the past 20 years, major advancements have brought this into a much larger spotlight. There are two predominant approaches to face recognition. Those are the geometric, which are the feature-based, and photometric, which is the view-based. And there are three main algorithms that have been tested and studied over time. And the three that have been proven to work best are the principal components analysis, PCA, linear discriminant analysis, LDA, and elastic bunch graph matching, EGBM. The first is principal components analysis, in which the images being compared must be the same size. And these images are normalized to align the eyes and the mouth of the picture. And this dimension of data is reduced to a low-dimensional structure of the facial patterns. And this basically removes information that's not useful, and it breaks down the facial structure into an uncorrelated component known as an eigenface. And each face can be represented as a weighted sum and stored in a one-dimensional array. Both images that are compared for differences between the features, and the images required for this are full frontal images that are of the front of the face, if it is to yield good performance. And this is an example of what the eigenface comparisons look like. You can see that the facial structures are broken down, not as clear. The next is linear discriminant analysis, and this is a statistical approach for classifying samples of unknown classes based on samples of known classes. And this technique aims to maximize between-class variance and minimize within-class variance. And as you can see, there are 6 different blocks, and these are known as classes. And between each class, there's a larger variance. As you can tell, the facial characteristics are much different. However, within each class, there's a minimal variance because many of those faces look very similar. And the last is elastic bunch graph matching. This relies on the concept of the real face. There are non-linear characteristics such as various illumination, whether the picture is indoors or outdoors, the pose of the individual, whether they're standing straight or leaned over, as well as the expression of the individual, if they're smiling or frowning or something else. This face is projected onto an elastic grid, and the nodes describe behavior around a given pixel. Shape detection and feature extraction of the face occurs here, and difficulty in this lies with being able to pinpoint the landmarks, and this can be achieved by combining PCA and LDA methods. And this is what the EGBM analysis looks like. There are 3 main types of errors with this recognition, and those are type 1, type 2, and failure to enroll. A type 1 error simply states that authorized conditions are rejected, which is also known as a false reject, meaning that an authorized person is denied access. And on the opposite end is the type 2 error, in which unauthorized conditions are accepted, also known as a false accept. And this is when imposters unrightly gain access to a system. There's also the failure to enroll, in which the technology is unable to read the characteristics of a given person for various reasons. An example of a secure system would come from combining all 3 categories, meaning a keypad with each key position moving to a different location, and including a biometric with a low type 2 error rate. And it's important to test these devices for errors over time, because you have to monitor a system before use of a new identification system, as well as giving users time to adjust to the system. And you should implement only when the error rates are very low. So to recap, I discussed the 3 categories of identification, which are knowledge, possession, and biometric. And I also discussed the 5 types of biometric, which are fingerprint, iris, voice, dynamic signature, and face recognition, as well as the 3 types of errors, type 1, type 2, and failure to enroll. Are there any questions?